All right. I have recently read or reread chapter 5 of Three Easy Pieces, Operating Systems 3 Easy Pieces, which is all about the um, process API. How do you start a process? How do you kill a process? Wait on a process? So we talk a lot about functions like fork and wait and exec. Those are the main three. And there's also pipe and kill and other stuff. So, as a way of testing my retention of the knowledge and my understanding, I am going to try to build a shell, tiny shell, right? Because I think that as a project, well, not sort of really a project, more just like as an exercise, is a nice way to sort of practice using some of the API stuff, process API things, function thingies, right? So, as a bit of like not revision, but what do you call it? Like as a little like background, with a little bit of theory. If we discuss, oh my pen. If we discuss how a shell works, right? You think about your terminal, and you think about how you have some ability to type in some input, and it just you put in some command or specifically you're putting in the name of an executable, and you punch it through. All right, hang on. You punch it through, and it gives you sort of the name of, in this case, it lists out your current directory, the things in your current directory. How does that work under the hood? Well, your shell, your terminal, like I'm using ZSH, you can have bash and stuff as well. The shell is a process, right? Which that is, it's a running program. So the shell is a running program. And specifically, its primary job is to wait for user input. And so when user input comes through, what happens? Well, in terms of processes, in terms of what the chapter is talking about, what it does is it first forks. So step one is it forks. And what does forking do? Well, it makes a second kind of twin process, or specifically a child process. So it's a child shell process. So this guy's the parent, this guy's the child, which will then be responsible for sort of executing the user's input, right? Specifically the executable that the user provided in here. It's the child who is responsible for handling that request, basically. How does it do that? Well, there's this other function called exec, and technically there's a few variants of this. The function itself is not called exec, I think, in C. Maybe there is, but there's a few variants. You call some sort of exec function, and I'll talk a bit more about its properties, but basically, that in turn, how do I draw this correctly? It doesn't create a new process, it actually replaces the child process with sort of a separate, it replaces this child process with new code or a new process that is able to actually run the desired executable. So let's say, for example, if someone says ls as the input, listing the directory stuff, the outer shell, the parent process, which forks to create a child. The parent still exists in that point, but the fork creates a child, which then calls exec, which then runs ls. And the cool thing about exec, and I'll probably say this again, but exec, if successful, doesn't return. So when if exec is called successfully, it's as if this child process never even existed. This child purely exists to call the exec, and once the exec is called, ls will run. And then when that terminates, all we are left with is the original parent, which will, after doing all this job, will wait for more user input, which is exactly what happens here, right? What's happening under the hood is you put in some command, right? cd tiny shell means I want to change directory into this tiny shell directory. You punch enter. The parent process, which is this shell program, forks to create a child process, and I sort of almost identical process, but with a separate memory space, separate lifespan kind of thing, separate but very, very similar in terms of it's sort of running the same instructions. But that child process will then be responsible for calling an exec function, which will then be what triggers the actual cd command, because of course cd is an actual program. I should be able to find it. Cat bin. Oh. Okay, apparently that's it. Sure. Or like ls? Oh, maybe it's like user ls? Nope. Oh, my bad. So if I go bin ls, then apparently this is kind of the source code or whatever of ls. We don't have to look too much into that. But the idea is, you know, when the things you're punching in are executables. So calling the exec function, that API call, will make that executable run. So basically, my intention is to try and make that workflow happen. So I'll probably need some... there's a few things I need. I think I need this guy because that's like the Unix standard library thing. Anything else? Probably. There are other features like pipes and redirects, which I will talk about at some point. But for now, I just want to see if I can get the main thing working. So we need like kind of a while loop. While true, which I will include. So what is our workflow? We take in standard input, then we fork, then we do something else. In the child, we call exec. In the parent, we have to wait, which I'll talk about as well. In the child, we call exec, and then, yeah, that should be it pretty much. So I need like a buffer to take in the standard input. So hash define buffer size. 100 characters should be enough. That should be fine. And I can make that buffer outside. So char input buff size. That's fine. And then we'll just make it printf. We'll just do kind of like maybe like an asterisk or something. Yeah, that should be fine. Space, and then fgetS is like the good way, right? fgetS, I want to put, using this buffer, I want to, wait, is this not how, wait, does fgetS, does size just mean the size of the actual buffer, or does it mean the fget function reads at most one less than the number of characters specified at most? Reading stops if it hits a new line. Okay, that should be fine. So yeah, I can just say buff size, and then taking it from standard input. Cool. So you do all that, and then you say, now we fork. So process ID equals fork. So if you think about what's happening under the hood, you can imagine you have one process running at the moment. This is the parent. When you call fork, both the parent and the child exist, right? and in terms of where they're executing from, both after fork start executing after this line, right? So the child, when it kind of awakens, when it exists, begins its execution after the fork call. It doesn't sort of start in the main at the start of main or anything like that. It starts over here. So how do we kind of work with both processes? For first things first, we have to check if the PID is less than 0. That indicates some kind of error. So standard error, fork failed, right? Exit 1. Else if PID equals 0. So this is the thing. Fork returns negative if an error happened, 0 if you are the child process. Because you got to imagine, like, this code is running in two places now. It's running in the parent and running in the child. And depending on if you're the parent or the child, the value that gets returned will either be 0 if you're the child or non-zero if you're the parent. In fact, for the parent, the return value will be the process ID of the child. So if it's equal to 0, that means we are in the child process, in which case we have to call stuff. We have to call the exec function, which I'll do later. And then so else, that means we're in the parent process. We have to say, what do we have to say? Wait. Let me remember something. So I think it's PIDT. Is that right? Yeah. I think this can be PIDT as well, actually. From memory, is this the right? No, probably the second page. There you go. Blah, blah, blah. So yeah, so wait, what in the parent, the wait function waits, suspends, in this case, the parent process, pauses it until the child process terminates, right? So that's all. So we're basically making sure that the parent doesn't do anything until the process in here with the actual executable, until that's done. So that's all wait is doing. And I just have to check if wait is okay, so -1. So I don't think I have to actually save the value. If wait is less than 0, I forget what this is for. There's some like extra parameter you can give, but I don't think I've ever used it. So if wait doesn't work, then fprintf standard error wait failed. Otherwise, that's it. Otherwise, we can kind of just go back to the start of the loop and go again. So yeah. Do I have to break out of here in the child process? Is that what I have to do? Nah, I don't, because the exec will basically clear out everything. Yeah, we should be fine. Okay, so what do I have to do? I think so yeah, I'll just show, I think it's 3 exec. Yeah, so these are the sort of 6 functions, 1, 2, 3. Yeah, these are the 6 functions that you could use to execute a file. Maybe as an example, I'll just comment all this out and I'll just show, let's say I say exec, what's an easy one? I think the first one's pretty good. Maybe one with the arrays. We'll say exec v. Nope, we'll say exec vp. Exec vp is a good nice one. Basically, if I give, I think I have to put the actual address on the heap or something. Like I actually need the address of something. If I say char star program equals ls. No, stop. ls. And then I say, then what? Char star args equals ls Does this work? Null? And then I say program, and then the args. This may work, we'll see. So what have I done? I have specified the string of the program that I want to give, and then this is all the arguments, including the actual program. So like this, you can think of this as command line arguments, but it has to be null terminated. So if I just read that again, I think it says somewhere. So yeah, here, this is a different version, but they describe the list of one or more pointers to null terminated strings. The first argument by convention should point to the file name. That's why it has to be ls. But then the list of arguments has to be finished with a null terminator. And I think that's true for, so that's one of the versions. That's for these functions, but for execvp, here you go. For execvp, the array of pointers have to be terminated by the null terminator. So I think this will work. I'm not actually 100% sure. So ceiling. There you go. So yeah, running my a.out program is the same thing as just running ls. So we can use this execvp function, or system call specifically. I keep calling them functions, but technically they're system calls. We can use this guy to actually do things correctly. But I've got to be a little bit careful, because I have to ensure that I actually do my argument stuff correctly. So we understand generally that arguments are separated by white space. So I think that's how I will do it. Yeah. So bringing back the original stuff. So in the child process, we have to first pass all of the arguments and put them in an array, specifically a char star array, string array. And then we can use execvp to run the executable requested by the user. So if we do something like, how do I do this? I need a buffer, don't I? Oh no, we did the buffer. Did we do the buffer? Yeah, we did over here. Could I have done this inside the child process? Ah, whatever. So I have to, so the buffer will have all of the just individual characters just put in, standard input, nice and simple. So if I say for, does f gets put a null terminator on the end? I think it does, right? Man, it has to, surely. Yeah, okay, good. For char star c is equal to the buffer. What do I call it? Buffer? Or just buff? Or what do I call it? Input. Oh. The character itself is not the null terminator, and we increment the pointer. So for each character, if int num args equals 0, we'll say, if what am I doing again? Sorry. I have to build up each argument. So I have to like copy it across. Right. I have an idea, but it's kind of dumb. Does it? No, that's dumb. Sorry. If C is like a white space character or somehow, you know, kind of thing, if it's some white space, then we have reached the end of an argument. So we can say something along the lines of, do I need like a current arg thing? What do I want? What do I want? I just want to make sure I don't like, I want to make sure I get my addresses right. So iterating through the buffer input, and then okay. I don't really want to use the heap. Surely I don't have to use the heap for this, right? Like, so we'll say char star args max args. Do I have to give a constant for that? Hash define max. We'll say like 30 args or something. Char star current arg current. I refuse to use the heap for this. Hash define max arg length, as in the length of a single argument. We'll say is like, I don't know, 200 characters. Maybe I do need to use the heap actually. Because how do I make sure it persists? Maybe, okay, hang on. Maybe I don't. Maybe I do. Oh, I don't know. Okay, let me try something. I already forgot what I was gonna try. Oh yeah, char star arg start equals input. So we're gonna have a pointer pointing to the start of each argument, and then we're gonna move C along until we hit the white space. Until we hit the white space. If we hit a white space, we know that everything between arg start and C should make up one argument. So we'll do like a double for loop. And so I should be able to be like, current arg, I declare that. And for char star current equals arg start, current is less than C plus current, and then we copy across. I might need a increment thing. Current arg at I++ is equal to current. And then current arg at I++ again equals an alternator, I think. What if you put like a bunch of white space? Oh yeah. Cool. Wait, so char star points to input, but in like that could be white space straight away. You know? So instead, what if we say while arg start is not equal to the alternator, and it's a white space character, or in my mind, the only white space characters are spaces and tabs. All right. We should move argstart plus plus, and then if we go to the end and argstart is equal to the null terminator, then that indicates that we didn't actually do anything. We didn't actually put. They just hit an empty. They just gave an empty string basically. So I think I can say exit. We can basically kill this this child process, and then I hope, and then otherwise we know that argstart is pointing to a non-white space character, so we're pretty confident that's the first argument. For C equals, and I won't say equals input, I'll say equals argstart. So it's definitely also pointing to a non-white space character. C is not the end, C++. If we hit a white space character, we know that that guy is pretty, legit. For char star, yeah, so then we copy across, we get the current argument and all that. And then after we do that for loop, we know the current arg now exists. Wait, but yeah, this has to be on the heap surely, because otherwise this doesn't make sense. Okay, I'll get the string. Because after that for loop reruns, the concern becomes what? That memory is no longer really owned by the program anymore. So that doesn't really make sense. So I think I need to stir it up a little bit. I was trying to get away with it, but I don't know if I can. So I give that copies it all onto the heap. I've really overcomplicated this, but anyway. Args at num args plus plus equals that guy. And so now we have C pointing to C pointing to white space, argstart pointing to that old argstart. We need argstart to point to the new argstart now, the new argument start. What if I say else if is not a white space character and the character before was a white space character. So what am I saying? What if this character is not a white space character and the previous character was a white space character and C is not at the very start is important. Else if C is, greater than maybe argstart, I can say. This is so dumb, but anyway. if we've moved on from, if C is pointing past the argstart and is pointing to some character and the previous thing before it was a white space, that indicates that this is the new argstart. Then C will iterate along until it hits another white space. Then it will go from arg start to that white space, not inclusive, and copy it across, and then stood up it and put it into args. I hope. And then yeah, else what the only other option is C is pointing to a non-white space character, but it's not the start of the argument, is what I'm arguing. In which case, that's not, I don't really care. I feel like I could have done this way cleaner, right? I could have been like, if I am using stood up, I don't need to do this here. I can do this outside. And I don't have to wait for the white space character. I can do this on hand. If C is past the arg start, C is not a white space, and the previous thing was a white space, if C is greater than the arg start and C is at some white space and, okay, I think I'll put, and I need to make a helper function about white space, and before C was not some white space, okay, this should be it. Goodbye. So if C is definitely, if there's definitely something behind C that we can use, C itself is a white space and the thing before C is not a white space, then that translates to C, from arg start to C, we can say that args at number of args plus plus is equal to stood up input stood up at current arg, and the current arg idx should reset to 0. So I'm doing this, yeah, I need this guy. Else if C is past the arg start, C is not white space, and the previous guy is white space. Previous guy is white space. Then we have found a new arg start. Arg start is equal to C. Current arg idx is equal to 0. Maybe here I should null terminate, right? So current arg at current arg idx should equal the null terminator. Then we should add this guy to the args, and current arg idx should go to 0. Otherwise, arg start, we have found current idx goes to 0. I don't think I have to do that because I feel like this would have already done it for me, but whatever. I think it's just redundant, that's fine. Else, we've just hit a nice normal character, no white space, just part of the argument. So current arg at that this guy, what? No, I want the whole word, thank you. Should equal C. I think. This is my grand plan. So this is how I've tried to build the argument array thing. Then man3 exec, which one was it again? Was it exec VP? Exec VP, I want the current arg0 is meant to be the name of the file, and then, no, not current arg0, sorry. Args at 0 should give me the name, and then the total args should tell me this guy. All right, let's see if this works at all, and then if it works, I'll explain what's happening when this gets called, because I feel like that's not trivial. All right, so let me just read through this one more time. You have a number of arguments counter. That's going to be used for indexing. You have args, which is an array. Very good. Then you have arg start, which is equal to input. Sure, that's going to be the pointer pointing to the start of an argument in the buffer. So while arg start, is that how I'm really doing this? Oh no, yeah, wait, this is different, sorry. While arg start is not the null terminator, and it's a white space character, increment arg start across. If arg start is equal to this guy, while arg start is equal to, if it's equal to the null terminator, then that indicates that we just gave nothing. So I think exiting 0 is correct. I could be wrong. Exit 0 might blow up everything. Maybe I'm just meant to say like return or something. Return 0. But whatever, it's fine. For now, because I don't... Normal program termination. I don't know. I think it is just for that child process. Int arg idx equals 0. So this tells us like this is going to help us copy characters into the current arg array. For C starting at the arg start, which should be pointing to a proper character now. C not the null terminator, we're not the end of the input. C++. If we've moved past the arg start and it's a white space character and the previous character is not a white space character, then that tells us that we have hit the end of an argument because we found a white space and we've gone past the arg start. So that means that we should add a null terminator, then we should move this guy. We should first copy him onto the heap and then move that address into args. Get the address. And then we should reset this to 0 so that we can overwrite the current arg array correctly. Else if C has moved past arg start, C is not a white space character, and the previous is a white space character, then we can make arg start at C because we found a new argument. Okay, the issue happens when what? The issue will come when we hit the null terminator. When we hit the null terminator, this wouldn't have run because you will have some stuff. You hit new line, and then you'll have this argument. Whoops! You'll have this argument which never got added to the thingy. Will never get added to the args array because it would have hit the null terminator, terminated out of this, and this thing never would have run. So I think at the end of all this, I have to say args at num args is equal to strewed up, and I have to say current arg one more time. That should copy everything, any remaining characters onto the heap. But I might have to first do null terminator stuff again. Current arg idx. Might have to do that first. And then do this, I think. Okay, let's see if this works at all. Nope. Okay. Oh, I really messed that up. Oops. Did I not include the... I did not. Can't use exit without that. And I need this as well. So hash include syswait. That's the library that has the wait function. Okay, let's see. What? Oh, my bad. That's actually interesting that it did that. That's good. Because then I can... Okay, here we go. ls. Oh, it didn't work. Oh, I didn't actually do the exec stuff, didn't... Oh, I did. Let me print everything for int I equals 0, I is less than the number of arguments. Printf arg percentage %d is percentage %s. New line. I missed. So I and then args at I should be the pointer, right? So that should be fine. There may be an issue with there may be an issue with how I'm handling the strings, which is causing it to not save or something. Ah. Okay. Cool. If I do like ls-a. Wait, how come the dash didn't come? You know what I should say actually? If current arg index is greater than 0, then do this. So I was saying, like, you know, that's going to be one more argument, but if that might not necessarily be true. How come the dash didn't show up on here? I'm confused. .530. Okay. So if C is greater than arg start, and it's a null, it's a thingy, and the previous one is not a thingy, not a white space, then end it. Let me try something. Printf arg start pointing at %c. I'll say arg start actually. So I would have thought that it would point to this guy already, because that's the non-white space character, and before there was a white space character, semicolon. But maybe I'm misunderstanding something. And then I would have thought that it hit then. Ah, of course, because I have to actually add it to the, I'm overriding, that's the problem. Current arg should do that. So I actually add the dash because I didn't. Yeah, okay, that makes sense. Whoa, what did I do there? Yeah, okay, good. So that's working. So it seems to be doing the correct stuff. Why did this not work? Like, just to clarify, what I'm trying to do is basically, I have char. Ah, because it has to have a null on the end, doesn't it? That's probably why. I said it and then I forgot. So I do all this, and then args at I plus plus. No, at num args plus plus equals null. Has to be null terminated. Now try. No. Ah. Okay, let me try to I'll just comment all this out for now. Within the I mean, the fact is I was printing stuff, which means it's getting through this whole thing, and then it printed that, which means it got all the way up to here. I'm assuming that worked. But that one didn't. How intriguing. For what do I want to do? So I just want to do this manually again because I want to have a template. So I need the char style. I need like this guy, and I need an array. So I need like char star args 2 equals stirred up, and like we'll say dash a. I spelled this wrong. And we need a null in there as well, right? So if I do this and then do args, and I run this, oh, I did that again. Whoa. Oh, my bad. My apologies. Oh, fair enough. Oh, not WC, sorry, LS. But it did work. Yeah, so that's the LS. With the dash A, of course. Fine. So I have to now modify it so that it looks like what my thing looks like, which is, I think it has something to do with the, okay, let me not worry, well, let me not bother with this dash A, and let me say I have my current argument thing, and what I think is happening is this, right? And the fact is, it was printing that out correctly. It was saying that the arg0 is ls. So char star args this is basically what I'm doing. I'm creating current arg on the stack, then I'm using stirred up to move it onto the heap, and I'm getting its address and making that and adding it to the args array. And then in terms of using this, what I'm doing is I'm saying args at 0, and then args. I also need the null in here, which I should also be getting added. So if I compile this, what happens? It does work. So there's some discrepancy between what I've done literally here versus what I'm doing in code, like generally speaking, here. Okay, so I've done something silly. It probably has something to do with the... I'm actually not sure. I'll just say this is my template. I create a current arg and I move it onto the heap. I eventually null terminate that guy. The fact that I'm able to print the args accurately indicates that I'm putting the null terminators in the right spot. Here and here if necessary. I want to check one thing. Oh. Oh, my apologies. What? No such file or directory. So when I put a space, it at least does something. If I put no space, then it just... So that means when the white space gets hit, at least it's doing the right stuff. If this is a white space, and the previous guy is not a white space, then null terminate it. Num args plus plus. I'm so confused. Final arg equals ls, yeah. Just want to double check that there's no like weird white space or anything going on. Oh, my bad. Is that dodgy? Yes, the length is 3. String length doesn't count the null terminate, does it? Returns a number of characters that precede the terminating null character. Interesting. So what? That means there's some weird like extra character being added. That would make sense as to why yeah, hang on. That would make sense as to why it's not finding the executable. Hang on, so yeah, so that's 3, and then it doesn't notice that there's no nothing happens. If I do ls with a space, it knows that this is ln with a thing of 2, and then arg1, maybe it's just that space. No such file or directory, so what I don't understand why something to do with the new line, isn't it? Because, whoa, if I do ls space, that's fine. If I do ls and then new line, can I do that? Do I even? Okay, it's definitely the new line. The new line is causing some problems, which is fair enough. So what, while it's not equal to the new line? There you go. Okay, starting to get somewhere. ls-a, whoops. Cool. ls, I don't know any other options. wc, how do I use this again? Oh, I broke something. Oh, no, it's not. It's waiting for input. Or maybe I did break it. Wait, how does wc work? What? I know that you're normally meant to give a file or something, but I thought maybe standard input was... Oh, you do control D. Something tells me that's not going to play so nice with mine. Oh, it did. Cool. Okay, so it's to do with the new line. The new line's is part of the scanned in input, which is fair enough. I think I didn't realize that because I thought it said something along the lines of, oh, I should have read it properly. There you go. See, the manual pages will never let you down if you're willing to open your eyes. Okay, so yeah, I could have avoided a lot of time. I could have saved a lot of time. Okay, I'm going to make a proper is white space. Given a particular character, if c equal return c equals a space or c equals a tab, and there's of course others, but I mean this should be fine. So if it is white space, the arg start, that is, and then if you are white space C and the previous thing is not white space, damn, I forgot that. I'm annoyed now. Is not white space, so it's not white space, this guy, and the previous guy is white space, like so, then we found the arg start. I kind of back this a bit more, else current arg is this guy. So yeah, and then if this, I think, is still wrong. Let me just check. So, because if I go man fget, nope, that was wrong. That was completely wrong. If I do clang, and then if I do ls with a space, but if I do ls without a space, oh wait, I guess it fixed itself. Oh, because it was the new line. No, I don't know. What, wasn't there a thing where it was doing arg1 when there was no arg1? Maybe it must. That must have fixed it. Okay, let's get rid of some prints. Don't really need you anymore. Thank you for your help, and then I don't need you anymore, really. Okay, I'm curious about one thing though. Okay, what I will do is if string compare input with quit equals 0, or string compare input with q equals 0, then breakout, I guess. Just that we have like a normal exit thing that isn't control C. I think that's a good idea. Surely, right? Oh, I missed. What? Did I do that wrong? This is the parent process, I believe. Input and then standard output. Wait. No, just to clarify. Yeah, it's saying quit. Why did that not work? Should I say exit? Will that make you feel better about yourself? No. Wait, I got rid of the print. Wait, what? Am I tripping out? Oh no, I didn't. Sorry. New line. It's a new line again. Right. Is that the best way to do that? I think yeah. Let's just do a thing where we strip strip the R space, the right to white space, given a particular character, a particular string. Probably gonna need the string length, right? Or we could do this like this: for int, for char star c equals s. This c is not the null terminator, and we're incrementing across. And we'll have a thing like R space is equal to, we'll call it null for now. If is white space given the character, then if it's not white space, then R space is equal to null. Like, okay, there's no white space at this point. There's no R white space, I should say. Else, while is white space given S, the particular character at S, increment S across. While S is not the null terminator. is not the null terminator, and this is the case, if S equals the that is, if S equals the null terminator, then I guess S at 0 equals the null terminator. Okay. Otherwise, we're pretty confident that we have some characters in here. S points to the very first non-white space character on the left side. We iterate through. If it's not white space, then R space equals null. Else, if it is white space, but if C, well, this is redundant, but if C is greater than S, we already know that if it is white space, we know C is greater than S because S isn't pointing to any white space, so C has to be beyond S, but whatever. If C is greater than S and C minus 1 is white space, so if it's not white space, there's this. Else, we know it is white space. C is white space. If the thing before it is not white space, then we have found, then R space should equal to C, I think. I believe this is true. I believe this is true. I am hopeful this is true. The earliest instance of R space is at C. And then you iterate, and then like if you see, if C is pointing to white space, but the previous thing is also white space, then nothing will happen because you've already marked that earlier white space as the right white space. And you iterate, then you might hit another normal character, in which case is white space will hit to false, so R space is null. Then you might hit some white space in the previous, yeah, okay. So when it's all said and done, I think you can say R space should equal the null terminator. That is, sorry, if R space, if it's not null, then this is the case. And then you can return out. And we're using addresses, so I don't think you have to actually return anything. Yeah, so if I literally just call this strip R space, given the input, I shouldn't have to deal with any more weird new line things or anything like that, I hope. Bang, alright, so I don't have to worry about that. And that should just mean that, oh. Maybe this is this now? I've broken things, unfortunately. But at least the quit works. There you go. Okay, yeah. So now, because now you do have to look. I would have thought that I got stuck in a infinite while loop though. I guess here you'd be okay because you eventually got out because you would have hit the LS. That's fine. If argstart is equal to null terminator, that didn't happen. But before it said if it's equal to new line, which also wouldn't have happened because it would have hit the L. And then it said for C equals argstart, C is not the new line C++. Yeah, I would have thought here it would have, because I never break out or anything, so I would have thought here might have gotten stuck in an infinite loop because before this said new line, new line, new line, right? But, like I would have thought here, char C equals argstart, C is not the new line, C++. So maybe I'm not getting rid of the new line at all, because it surely would have never terminated if... if arg start is in white space and the previous thing is not white space, then if this is white space and the previous thing is not white space, then I have found the end of an argument. So I add a null terminator, I move this to the heap, and then I reset this to 0. And I also move this guy into the argument array. Else if C is arg start and it's not white space, and this is white space, if you're not at white space, and the previous guy is at white space, we found a new starting for the argument. This sets to 0, and we should add this to the array, which makes sense. Else we should just add the character to the argument, and then if this is greater than 0, then current arg should null terminate it, and then add this over here, null terminate the overall list, and then do this. Yeah, okay, whatever. So now if I do like, let me make a random file, like should be able to work with files as well. Will this work now? Cat. Oh yeah, tab doesn't work obviously. Yeah, oh. My bad, I didn't put a new line. Oh, and of course the scrolling doesn't work either. Because this is a console app, whereas the actual shell is a graphical thing, so it can listen for keyboard events and stuff, but I don't do that at all. There you go. So cat works, and yeah, all the normal Linux programs are accessible because we're using the exec system call. Now, redirects are where we start looking at file pointers, but I'll do that later. For now, I'm happy with this. This is like good start to how things work. And oh yeah, one thing I just wanted to quickly explain more for myself. When you call exec, the child process has been replaced by the new executables process, like cat or ls or whatever. That child process ceases its code segment, gets completely replaced by the code or the instructions of the executable that we care about. So in that sense, when this parent is waiting for its child to finish, what it's actually waiting for is the actual executable to finish. So I'm assuming their process IDs are the same then. The child versus the ls or whatever. Like I'm assuming that the process ID is the same. That the executable sort of takes on the identity of the child process in terms of taking on the same ID. I would think, is my understanding. But yeah. There we go. Basic shell. What about grep? ab.d, and then it's looking for. Oh, it didn't work. Wait, what? Oh, because the quotes mess me up, doesn't it? I spelled grep wrong. Oh, the scrolling. Oh god. If I do it now, it'll work. Yeah, now it copies it. Because the quotes aren't quotes. The quotes are literal quotes. The quotes aren't just to wrap around. I'm assuming it delimits it, right? Like if I want to actually put a quote in grep, I'm supposed to say grep -e and then like ab quote, like with a escape thing, right? ab quote d, I'm assuming, yeah, that copies. But if I do ab \quote d, I'm assuming something, yeah, it won't copy because that counts it. That's a literal backslash with a literal quote, whereas this is the escaped version of it. Whoa, no. Yeah, okay, fair enough. So quotes are another thing I could think about, but that's more technical. That's like more like good design rather than like operating system study. Anyway, that's my shell. I'll call this shell, and I'll call the executable. Did I just kill the whole? Okay. I'll call the executable shell, and at some point I'll probably think about redirects and stuff because that's part of the chapter as well. But for now, that's my shell.